graph transformations of logarithmic functions. Well, first, let's just talk logarithmic functions in general. The parent function. The parent function of a log is f of x equals the log of x base b. Right? No other things. The only argument we have is x. So when we're graphing this, we start with our x-intercept of 1, 0. Then we plug in 1 for the f of x. Remember, this is the same as y. And we solve so that we can find another point. We might need additional points. We know the domain starts at 0, infinity. The range is negative infinity to infinity. And the vertical asymptote, right, if this is my coordinate plane, the vertical asymptote is x equals 0, meaning our graph can never touch that line. Okay, now, when we get into the transformations, we are moving the logarithmic function around. So first with the horizontal shift, that is noted in our function by the values inside with our argument. Okay, so if we have inside here a minus h, well, let's use numbers because sometimes numbers are easier. So if I would have the log of x minus 2 base b, doesn't really matter what the base is, this is going to shift right 2 units. And if I have log of x plus 2 base b, this shifts left 2 units. So you can see based off the x and the y. Now, if you forget that, remember the idea of domain. If you set the argument, let's just say this one, set the argument greater than 0, because we know logs must be positive, and solve. That means x is greater than 2. So on our coordinate plane, here's 2. It has to be greater than that. So that'll also help you remember which way am I moving if you think back to the argument must be positive. Now that's the horizontal shift. What about the vertical shift? Well, that's noted in your function outside of x. Okay, so there will be a number out by itself, not with the x inside the parentheses. So again, let's just say we have log of x, base b. We don't care what the base is. And then let's have plus 2. And then let's have log of x base b minus 2. So the first one, plus 2, would shift up 2 units. And the bottom one would shift down 2 units. Right? So that's kind of like the basic idea. Now, if you remember those, that makes things a lot easier. The only other thing we haven't talked about is when you have a factor inside. So if you had like the log of 2x base b, then we get into vertical stretches and compressions, which I believe we get to later. Okay. So we're going to graph the log of x plus 3 minus 2 and the parent function. So I like to graph the parent function first. It makes my life easier. So that's what I'm going to do. So the parent function is the log of x base 2. Just a straight log with a simple base. That's it. All right, so if I'm graphing the parent function, I know step 1 is the x-intercept, which we know to be 1, 0. 1, 0. And then we say, okay, what if I plug in 1 for y? So log of x base 2 equals 1. That means 2 to the first power is x, right? Because 2 to the first power equals x. So that means x is 2. So my ordered pair is 2, 1. 2, 1. I also like to plug in negative 1. The log of x base 2 equals negative 1, meaning 2 to the negative 1 equals x. So x is 1/2. So 1/2 negative 1. And this is my parent function. PF, parent function. All right, so we have the curve, right? Knowing again that the x equals 0 is my vertical asymptote. Now, switching, I'm going to make this one a little thicker, the line thicker. Switching to our graph of our function. Now notice that inside the parentheses, so part of the argument is x plus 3. What we just learned is inside the x is a horizontal shift, and plus 3 means I'm going to move left 3 units. And the minus 2 at the outside all by itself means I'm going to go down 2 units. So if we plot the parent function first, and we have 3 points, right? I've plotted 3 points with my parent function. If I move each one of those points 3 to the left and down 2, I will have my new function, my new graph. First thing I want to move, though, is the asymptote. So I know on my parent function that it's x equals 0. So if I move 3 units to the left, 1, 2, 3, this is my new vertical asymptote at x equals -3. Right? There we go. If you have different colors, if you have different, like a marker or a pen or pencils, use different things, even if it's just textures, to help you know. Crayons work great. All right, now I'm going to move every point. I'm going to start with my intercept. I'm going to move it left 3, down 2. So my new starting point is -2, -2. Then I'm going to move my point 2, 1. I go left 3, 1, 2, 3, down 2. And that new point is -1, -1. And then I have the point 1/2, -1. So if I go left 3, 1, 2, 3, down 2, 1, 2, 3, down 2. I'm now at -2.5, -3. And that is where my new graph is. So you can see everything should just be shifted left, shifted down. And at any point, if you're like, Becky, I'm never going to remember that, that's fine. Plug in values for x. You can always do that. Or plug in values for y. You can always go back to a t-chart and saying, well, what if x is 1? What does that make y? With logs, that can be a little uglier, but it can still be done. The nice thing about transformations is these transformations with horizontal, vertical, all of that, they're the same across logarithms, exponentials, quadratics. It doesn't matter the type of function. Transformation rules when it comes to horizontal and vertical shifts, always the same. Oh, and absolute value functions as well. So I hope that helps with graphing logarithmic functions and their transformations.